So you guys, you've seen this before. You've seen this exact question. You've just never seen it with these symbols before. So now this is saying, hey, I want the derivative. Derivative, like we learned yesterday, is the slope at exactly 1 point. The slope at exactly 1 point. So it says, hey, estimate the slope when x is 6. That little apostrophe is just saying, hey, go estimate that slope when x is 6. You guys, did I give you any when x is 6 in here? No. Can we still say, oh, it'll be between 5 and 7? Yeah. So you guys, we've done this a lot, but we just haven't done it with these symbols yet. So they're saying, oh, when x is 6, all right, let's go do change in y over change in x. What would be our change in y over change in x here? Done. 7 minus 5, you got it. If I were to say what those units would be, what would those units be? Boom. So again, you've done this before. This is just a new notation. This would be said h prime of 6. We got it. What about if I asked it like this? Is this still asking for the derivative? Yes. Does anyone remember how we say that? dy dx. Oh, and this is called an evaluation bar, you guys. It says, I'm going to just write it big. The derivative when x is -2. This is just an evaluation bar and saying, I want the derivative at this point. Did they give us when x is -2 over here?
No.
No, where would it be between?
Well, 0 and 3.
Well, couldn't we get a little closer, though? Wouldn't -2 actually be right between these two?
I thought it was positive, too.
Oh, I got you. I got you. All right, you guys. So this is, again, just another way to say, hey, go find me that slope. What minus what, y'all? Yeah, we got to put that 9 minus 1 or 1 minus 9 on top, though, right? Yep. So I just wrote 9 minus 1 because I don't know why. And -3 plus 1. And let's not worry about units because I didn't give you any. Bless you. We okay on that, you guys? All right. Okay. Then I said, oh, yeah, you want to let your calculator do this for us? Yeah. So to estimate the derivative, we can always use that average rate of change, but we can also use our calculator to get the exact value. So you guys, this is saying, hey, go calculate g prime of 1.2. Oh, interesting. I see what I was trying to go for here. Okay, yes, we could approximate. I'm not going to focus on that as much, though, am I? Nah. Yeah, okay. You guys, if they wanted to approximate, just like we've done up here, what did we do? We use points on either side of that value, right? On either side of -2, we use -3 and -1. What if I wanted to approximate g prime of 1.2? What are some x values on either side that I could use? 1.1 and 1.3 are on either side. So change in y, I'd say g of 1.3 minus g of 1.1. That's my change in y over the change in x. Here's my g. Let's go use our calculator to go help us find that. And I got 0.348 minus 0.499 because we got to go 3 decimals. And let's get an actual value. So I'm going to do change in y. And then I'm going to divide that by 0.2. And our estimation is that slope will be negative 0.756. If you go math on your calculator, do you see anything that might help us find the derivative? Yeah. Option 8 says deriv. I don't know why there's an N. I don't know. But it just says deriv. So you guys, you're going to hit option 8. And look what yours does. Yours say D and then D blank. So you're going to go type in that X button. Say, I'm going to do everything with respect to X. And then we're going to go type in our function. We're going to say X cosine of X. And then it has that little evaluation bar. You guys, where do they want that slope? When X was what? -1. Close. That's my next one. Yeah, 1.2. So I'm going to say when X is 1.2, enter. Did we get it? You got negative 0.756, and that was our estimation. So not only did our estimation, that was perfect. How we'd say this, you guys, is we'd say g prime of 1.2 is negative 0.756. And again, let's do our next one. Let's not estimate it. When we do math 8, when we do find the derivative, we're actually doing the exact one. So let's just go find f prime of this case of negative 1, because they asked for the derivative when x is negative 1. So you guys, I'm going to go math 8 on my calc. Then I'm going to say d dx, just so that we're always going to use x there, you guys. And then we're going to take x squared minus pi. And they wanted that derivative when x is, in this case, a negative 1. Anyone get it?
-2.
That came out beautifully. Okay, so now this one, there's a lot of words of saying how many values of c, which are just x values, between a and b, does the average rate of change, this is just my change in y over change in x, equal my instantaneous rate of change. And maybe you write yourself that little reminder. This one is instantaneous. And then this one is change in y over change in x. So this one is at 1 point. This one is at 2 points. So it says, how many times will my instantaneous rate of change, my slope at 1 point, equal my average slope? You guys, going from A to B, check out what my average slope is going to be. From A to B, there's my average slope. I'm just going to connect my endpoints. And my lines are not straight. I apologize. That should be a nice straight line. Would you say my average slope is positive or negative? Positive. Do you think that there will be another time where the graph, where my tangent line only touches once, that has that same slope?
No.
What about here? What about here? What do you think? Any others? Another one? And one more? What about down here? Do you think that I could draw a perfect tangent line there? No, because Henry might be like, I don't know, I'd have it go this way. And others might be like, I'd have it at 0 and I'd have it positive. Whenever, we're going to get to this in 2-4, it's called a cusp or a corner. We don't know what that tangent line is because it can't balance. It would just be like a teeter-totter. You know what I mean? As opposed to when my curve looks like this, my slope is positive, less positive, 0. You know, it has a slope. This is called a cusp or a corner, and we'll get to that. So how many times did my instantaneous rate of change, my tangent line, have the same slope as my average slope? 4. Ooh, okay, similar. Oh, I think this one's actually visually a little hard. Given this function, of the following values of x, which does the tangent line have the greatest slope? So let's go use our calculator, guys. Let's go graph this. And we might want to change our window. We'll see. We got this cool looking graph. And it says at which of the x values is the slope going to be the greatest? So this is f. I would, if I were you guys, I'd do trace. What's the first x value they want us to try?
-2.
-2. I'm going to do trace, -2, enter. At -2, what does your slope look? Positive or negative?
Negative.
So next to my answer, I'm personally just going to be like this, that my slope was negative. They want the greatest slope. Something that's negative is probably not going to be my greatest meaning most positive. I'm going to then hit -1, enter. You don't even have to keep hitting trace, you guys. We've hit trace once, so we can just type in different values. What do you think my slope will be there? Positive, pretty positive, I'd say, right? So I'm going to be like, all right, that one's definitely positive. How about at 0? 0, enter. What's my slope looking like there? 0, agreed. So I'm going to say that one's 0. And then finally at 1, enter. And that one's going to be negative. So what would you say? Where is my greatest slope?
B.
At 1, I agree. I'm sorry, -1, answer B. Very good, very good. Okay. Ooh, I'm going to show us another way to do this. Oh, yeah. I want to show you another way to do this. This is, again, asking for the slope of this function when x is 2. So you guys, let's go to our home screen, and we're going to type in math 8, because they want the derivative. We're going to say with respect to x. And let's go type in this function, e to the -x plus the cosine of x minus 1. Where do they want that slope? when x is 2. When x is 2, and I got that from right there. What'd y'all get? Oh, I don't have my... Did you? What did I do wrong? Because I did not get that. Oh, I messed up my parentheses. I messed them up. Cosine of x minus 1. Let's see if I get that. Did you guys get any of those? I got C as well. The rounding might throw you off.